Hello everybody, in this video we are going to learn about earthquake prediction and earthquake forecasts. So let's start with the earthquake prediction. It is the ability to accurately predict the size, location, and time of earthquakes accurately. However, it remains elusive even with today's technology and information, unfortunately. And because predicting earthquakes becomes, something that is very hard to do, therefore, scientists, prefer to do a more achievable goal of making long-term and less specific earthquake forecasts. Some people even say that earthquakes cannot be predicted because the mechanics of earthquake generations are just too complicated. Simply because there are too many factors that need to be taken into account. However, predicting specific times, location, and magnitudes for future earthquakes would still be, very useful, even though some people say that it is almost impossible to do at present time. Even though some people say it's very hard to do or it's almost impossible to do at present time, it doesn't necessarily mean that there has not been an earthquake that has been successfully predicted. So in 1975, there was one single earthquake that was successfully predicted, and it remains the only predicted earthquake in our history. So the mitigation efforts that were done at that time successfully saved an estimated of 150 excuse me 150,000 people who live in that region, and that region is represented by this green circle over there. All right. So what happened during this earthquake was that that region started to experience some unusual level of small earthquakes, as represented by these short sticks right here on this graph. As you can see here, we have some earthquakes, and then it stopped, and then we have another earthquake right here, and then it stopped again until it hits a bunch of other earthquakes before the main Haicheng earthquake occurred, represented by this tall stick right here on the right side of this chart. Okay, so because of that pattern of earthquakes, the geoscientists at that time, the local geoscientists at the time concluded that there was a big fault that was under stress, causing some smaller stock patches to fail, producing these, smaller earthquakes that we see before the main earthquake happened. Okay, so therefore, before the main earthquake happened, they alerted the people and ordered evacuation for people who live in that region, and these orders were mostly based on the cessation of small earthquakes because they were afraid that there would be a major earthquake occurred at that time, and it turned out to be right. um, because this 7.6, 7.5 magnitude earthquake of Haicheng in China occurred right after those small earthquakes. So it was a very success story, and it was a very great story to tell, actually. However, you know, even though it was a successful prediction that happened in Haicheng, China, just a year after that earthquake, there was a large city, nearby large city of Tangshan, that was destroyed by another major earthquake, which is about 7.6 of magnitude, that hit the city in July 28, 1976. So this is roughly a year after the Haicheng earthquake in the same region. Okay, so which is this region right here. Okay. All right. So, what happened during the Tangshan earthquake? This is the picture of the aftermath of that earthquake. As you can see here, there was a lot of buildings and houses collapse. This earthquake had about 7.6 of magnitude, and it struck this region early in the morning at 3:42 in the morning, and this is probably one of the reasons why it causes lots of damages and lots of casualties as well, because this earthquake caused almost 85% of the buildings in that region to collapse and become unstable, and at least 242 people, sorry, 242,000 people died during this earthquake. So what does that mean here? Both the Haicheng earthquake as well as the Tangshan earthquake occur, in the same region. Okay, so it tells us that earthquakes behave completely, even though they occur in the same region, they behave completely differently. So therefore, making the predictions of earthquakes become very, very tricky, and that's the reason why um, some people said that it's almost impossible to accurately predict the time, the magnitude, and the location, the exact locations of major earthquakes. Okay. So because predicting earthquakes becomes something that is very hard to do. Again, most scientists now, put more effort into earthquake forecasts instead. Forecast means that it's long-term estimates of earthquake occurrence, and there are several factors to consider to create earthquake forecasts. Okay, the first one is the scientists will look at the seismic gap along faults. So, what do we mean by seismic gap? Seismic gaps are areas along seismically active regions that have not produced any recent earthquakes. And this is something that we need to pay attention to because this could be the areas of fault that is locked up and due to blow. Okay, that means that the stress is still building up in these seismic gaps. Okay, so for example, here we have Aleutian Trench right here. This is actually a convergent plate boundary where the Pacific plate goes northward and subduct under the North American plate in this Alaskan region. Okay, so what happened here is that we have a bunch of earthquakes that have occurred. For example, here in this region, 1965, 1957, we have that earthquakes over there. So all of these red areas here, these are regions where earthquakes often occur. Okay. However, there are some gaps here in the Aleutian Trench where earthquakes never occur, or you know it's been a very long time for earthquakes to occur in that region. So for example, here we have one gap right here. We have another seismic gap here in the middle. And then we also have another seismic gap here in the east. Okay. So at least we have three seismic gaps here. These are the sites where scientists really started to, pay attention to. Okay. And the second one is the probability of recurrence of earthquakes. Now, this is the example of the effort to actually make predictions based on the probability of recurrence. So what happened here is that in the Park Filch section of the San Andreas Fault in California, there have been earthquakes that regularly occur. So they have recorded earthquakes with 6.0 magnitude right here, starting in 1857, 1881, 1901, 1922, 1934, and 1966. And based on this occurrence of earthquakes, they basically plot the earthquakes on this chart right here, and they can actually determine that the repetition time is roughly 22 years. So therefore, they anticipated that another earthquake of 6.0 magnitude will occur around 1988 to 1993. So they waited for the earthquake to occur. 1993 happened and nothing. Okay, not until 2004 actually. So the earthquake actually happened about 11 years late than predicted. But that's okay. I mean, at least they were able to predict, the same magnitude of earthquake, even though it's a bit, 11 years late than the predicted year. But that gives you an example of probability of recurrence. And the third factor that scientists take into account is to estimate the seismic risk of certain regions. So, for example, in the United States, we have good records of earthquakes. And for example, here is the record for earthquakes that have a magnitude of 4.0 and above from 1534 to 1994. So if you plot all the earthquakes on the map, you can actually see that there are some areas that have greater risk than other areas. So we have one area right here where we have lots of epicenters in recent history. We also have another area right over here, and then we also have some areas that have anomalously high number of earthquake epicenters in recent history. So based on that data set, we can actually create a national shaking hazard map as I showed you in this picture on the right side. Okay, so what you're looking at here is the red colors. For example, here we have the very red colors in the western part of the United States. This means these areas has the highest hazard probability over there. Okay, and of course the areas where it has a color of yellow right here, that will be the one that have the lowest earthquake hazards. um, of course, it's no surprise that the western part of the United States is red in this map because we know that we have the transform plate boundaries associated with the San Andreas Fault that goes along the California state right here, and then we also have convergent plate boundaries here in the northwestern part of the United States as well. So these two types of plate boundaries are the main causes for earthquakes to happen in the western part of the United States. Okay. And then the next factor that scientists take into account is to monitor the fault activity, basically. So these are the four factors that geoscientists like to take into account in order to create a long-term forecast, and the result would be something like this, for example, right? So this is the earthquake forecast in the Bay region of California, Northern California, right here. And by taking all those different factors into account, they were able to basically put up a number that there's a 62% probability of at least one 6.7 magnitude earthquake striking San Francisco from 2000 to 2030. Okay, and of course everything here is based on the plate tectonic motion and slip on faults and the other four factors that I already mentioned before. And because of this map, they have a recommendation that all people that live here, this green stuff here, these are all urban areas, so these people need to be prepared for earthquakes. This earthquake forecast, again, this is a long-term prediction, and this long-term prediction can assist planners to consider the seismic safety measures or helping people decide where to live. But of course, it doesn't help the current residents of seismically active area to anticipate an earthquake. All right, but this is the example of another hazard map that can be very useful for earthquake forecast right here. So here are the red areas where you don't want to actually live here because there's a greater risk of primary or secondary hazards of earthquakes in these areas. But again, I said that it doesn't help the current residents of a seismically active area to anticipate an earthquake because if you already live there, so there's really nothing you can do unless you want to move somewhere else, right? But there are things that local government can do for these people. For example, they can have a planned emergency response. They can put up some early warning system for earthquakes or maybe tsunamis, and they can provide public education and training for preparedness for earthquakes, and they can choose sites especially for critical facilities such as power plants and hospitals in areas where you have lower risk of earthquake hazards to occur, right? And then last but not least, they can do some structural reinforcement and protections in order to reduce the risk of building collapses. And those are the things that the local government can do. But how about us, right? Well, if you watch this video from areas where you don't feel lots of earthquakes in a year, for example, if you're in New Jersey, New Jersey has a much lower risk of earthquakes compared to someone who lives in California, for example. But this is still a really good stuff to know. All right. So if you live in areas where earthquakes often occur, the very first thing that you need to do is probably to identify safe spots in each room. Okay. So take a look around where in your room that you can identify it as a safe spot if there was an earthquake occur in your region. And you need to know how to turn off gas if leak is detected, because remember, fire is one of the most devastating secondary hazards for earthquakes. And then the third one, you can also make sure that you can access necessary supplies. And sometimes if you go to Amazon or some other areas, there's actually a little kit, a little kit that you can buy that contain some foods, necessary supplies to survive if earthquakes happen and you get trapped within your house. And of course, you need to be prepared to help others during an earthquake. And I think that will be it for this topic about the earthquakes and many things about earthquakes. Hopefully you learned something, and I will see you in the next video. Bye bye now.